Hi there and welcome back to 355 Code. Today we will be doing another HackerRank challenge. The first challenge that we tried was Insertion Sort Part 1, and today we will be doing Part 2. So if you haven't checked out our first video, you can do that on our channel. And while you're at it, don't forget to subscribe so that you can see the next HackerRank challenges that we try out and other videos about learning JavaScript. So as I said in the first video, HackerRank is a great site for really challenging yourself with problems that will teach you how to think in a way that will help you actually pass an interview and get a job. And there are different levels. We're starting here at the easier level, and it's actually organized really well in a way that helps you build up a certain skill set by set. So now we're in the sorting category. So we're kind of building up different kind of concepts within the world of sorting. And today we're going to be doing another form of insertion sort. So last time we kind of learned just how to take one item and insert it in the correct spot in an array. And today we're really going to be focusing on sorting an entire array. So let's just take a look at the guidelines for how to solve this challenge. So basically, can we use the same approach as last time to sort an entire array? And the goal is basically to go through the array item after item and do the same kind of insertion sort that we did last time. So we will compare each item to, in this case, the items before it. Last time we started from the end and worked our way forward. And worked our way back. This time we'll be starting from the beginning and going item by item, working our way back. So for example, if we take a look here, n equals 7, that is the size of the array. And the array here is on the bottom. So we start with 3, and we don't really need to compare the first item because there's nothing before it, and we'll see that when we're writing our code as well, so remember that point. So starting from 4, we compare it to 3. 4 is larger than 3, we make no change. Okay, same for 7. When we get to 5, we compare it to 7, and we see that 5 is smaller than 7. Then we compare it to 4. We see that 5 is larger than 4. We know this is the spot that we want to insert the 5. So there's a lot going on here. We also are iterating between each item in the array. And then we have a second iteration comparing backwards. And then we have the actual action of removing the item and inserting it in the correct spot. And at each stage that we make one of these tests or changes, then we want to print the array in this format. So let's really just jump in and try solving this. If you want to try by yourself before looking at our solution, the link to this problem will be in the description below along with the solution, and you can check those out before you watch this video. So if you want to follow along and see how I solve this problem, let's get started. So to start off, we're going to start by declaring 2 variables, because each time we iterate through the array, we're going to be comparing 2 things. And these things will be a certain item in the array and the item or items that come before it. So to keep track of the item that we are currently checking if we need to sort in the array, we're going to use the variable I. So let's declare a variable I. And to begin with, this I is going to be equal to 1. Okay, because for the sorts, we're always going to be starting from the second item in the array, which has the index of 1, because the first item has nothing to be compared to. And the second variable that we'll declare, we'll just call it J. And this will be the items that proceed the current item that we're checking. So I will change each time we jump from item to item, and J will change each time we compare that item to different items before it. So you'll see exactly what I mean in a moment. So I started J off from 0, and both of these are going to be changing in our loops. Okay, so it's quite obvious that we need to use loops here. And we're going to use while loops just because they kind of give us better access to the variables after the loop is finished executing. And that's also why I declared the variables up here. If we were using a for loop, we could have really just declared them inside the loop. So what are we trying to do first? So while, basically what we want to do is, as long as I is smaller than the length of the array, we want to be moving between items. Okay, this basically will go item, item throughout the entire array, and make sure that we test and see if we need to sort each and every one of them. So while I, and the length of the array, we get that as a parameter here. We could have also found it ourselves, to be honest, but since we have it as a parameter, why not use it? So while I is smaller than n, okay? So while I is smaller than n, we are going to be running through this array. And then once I is equal to n, we will be exiting that array. So, sorry, this loop. So, okay, within this loop, what do we want to do? Each time that we run through this loop, we will want to check that compare I to each of the items before it. So for this, we're going to be using another while loop, and we're going to be executing this as long as we're going to be executing this as long as the item in the spot of I is larger than, is smaller than J. Okay, then the item in position J. And 1 second, I'll explain that. So if we take, for example, this array here that we have on the side, so if I'm comparing 5, I'm comparing it with 7, okay? And since 5 is smaller than 7, okay, since 5 is smaller than 7, we're going to be running through the while loop again to check 5 against 4, okay? And it's important that we also add our increments. So for the outer loop, we need to add an I++, because basically each time we run through this loop, we're going to be adding 1 to I to move forward in the array. And here we're actually going to be adding J minus minus, because this we're checking backwards, as I explained before. Great. So now let's kind of just run a basic console to see that everything is working. So let's console here, and let's log the array each time. We haven't really made any changes to the array, and let's check I, and let's check J. So let's run this code. Great. So as we see, we run the first time, I equals 1. So we take a look at I seems to be working quite well, but we can see that we have a problem here with J. So let's take a look back at our function, and we'll see here that we declared J here on top, and we've been doing J minus minus over here, but we have no way of moving j along with I, because I is getting a plus plus here, but we actually want j to keep its relationship with I. So we started it off at 0, 1, but each time that we change our I, we're going to want to make sure that j is actually equal to I minus 1. Okay, so they're always going to be keeping that kind of relationship. So let's try running our code one more time. Great. So now we can see that j is changing. And in some cases, it ends up at 0, and in some cases, it ends up at a certain index. So where it's ending up at 0, those are the cases that we're not going to be making any changes. It basically means we went through the entire array, and there is no need to make a change. And here are the cases that we went through the array, and we do need to make a change. So one thing that we're going to want to do is start making our changes. So now what we're going to want to do is actually make those changes to our function. And the way that we're going to do this is similarly to how we solved the first insertion sort problem. We're going to add something called storage. And this is basically how we're going to store the item that we're moving from place to place, because we're going to need to remove it from the array, and we're going to need to insert it back in. And as we do that, we don't want it to quote unquote get lost. We're going to want to remember what that is. So let's declare a variable called storage. To start off, we'll just start it off as null. Doesn't have any value to begin with. And after we exit this while loop down here, that's when we're going to be making the changes. Okay, because that basically means we reach the point where the while loop has iterated to the spot that we're going to need to make a change. And the first thing that we're going to do, and we're going to be using the splice function here, and we're going to be removing an item and inserting it back in. So the first thing that we're going to want to do is array.splice. And the way that splice works is we give it an index where we're going to be starting the splice. Then we're going to tell it how many to delete if we want to delete any items. And then we can also tell it what to insert instead if we want to. So the first thing that we're going to want to do is to remove the item that we are moving. So to do that, we're going to be using the index of I, okay, because that's where it's located at the moment. And we're going to be removing one item, okay, and that's really it, okay. And then the next thing that we're going to want to do is to do another splice. And here we're going to be inserting it at the point of j plus 1, okay, because j is where it currently is not, we hit the point where we exited the while loop, which basically means that we need to put it right after it. And we're going to be, here we're not going to be removing anything, so we could just put delete count as 0. And what we're going to be inserting here is what we're going to be using storage for. So we're going to insert here storage. And before we do this, we need to remember to store the storage. So storage will be equal to array I. Okay, and now basically we've implemented the case where we are removing an item and adding it in. So if we run our code as it is now, we're going to see a certain problem. So So if we run our code as it is now, we are going to see that in terms of our output, we're getting the correct arrays. If we compare our output to the expected output, the only thing is that we still kind of have the J and I, which we can easily get rid of. The last thing is that we need to kind of reformat our output. So let's do those two things. So let's go back to console.log over here. And let's remove I and J. And for this array, we'll be doing the same thing that we did last time, which is basically just using the join method and joining the array together while leaving a space between each item. So let's try to run our code again. And excellent. So our sample test case came out correct. And now we can basically try to submit our code. And now it'll run it against more test cases just to make sure that we didn't get lucky just with one single test case. And again, this isn't foolproof. So even if we get all these right, that doesn't mean that our code will be correct for every single case. But as you see, we solved it correct for all the test cases that they have at least. And that means that it's quite likely that we have solved this challenge correctly. So that's the end here for learning how to do a full sort of an array. And this knowledge and skill is going to help us as we approach some of the future challenges here on HackerRank. So if you like this video, please don't forget to like and subscribe. The full answer code will be in the description below, and I hope to see you next time.